Okay, so in this steady state AC problem, they're asking us to find a voltage and a current in their time domain form. And before we can do anything, we have to calculate the impedance of these various components here, because we're going to use them in the phasor calculations. Now, for the time being, we're not going to worry about this component for reasons that you'll see later. So let's go ahead and use the equations for calculating the impedance. Here are all the impedances that are important for this problem. Now, in terms of figuring out what value to use for omega here, you can look at the source voltage's value for omega, which is given to us in the problem right here as 2, because the form for a phasor is some magnitude and then cosine omega t plus the phase angle. So here the phase angle is 0 and omega is 2. Okay, so there's all of our impedances. So basically in this part of the circuit right here, there is a total series impedance that is in parallel with this voltage over here. So therefore, this current I/O, that will just be this voltage over here over the total series impedance of this branch. So let's go ahead and do that really quickly. So the phasor form of I/O will be just the phasor voltage 25 at angle 0 degrees, which is just this right here, and the total series impedance, which will just be 5, and then the impedance of the 2 Henry inductor, or just J4. Now at this point you can convert the denominator of this into polar form and then do all the math involved. But when you do that, you'll get 3.9 at an angle of negative 38.66 degrees amps. Okay, so that is the current. And the very end of this will convert all of these phasors to the time domain form. So for V of t, we can see that in this closed path right here, we have a known voltage, then all series impedances in this closed path. So that gives us grounds to use a voltage divider. Okay, so here's us using the voltage divider. So here we want the voltage across the capacitor, so we put that impedance up top. And on the bottom is the total series impedance of this closed path, so these three right here combined. We're basically done here, so let's go ahead and write these two values as their time domain form. And now we're done. So all we do is we put the magnitude of the phasor up front, followed by cosine omega t plus the phase angle theta. So these are your answers right here. If this video was helpful in any kind of way, be sure to leave a thumbs up on it. See ya.